So let us discuss about vacuum circuit breaker. So we have already discussed about oil circuit breaker, in which oil is the arc quenching medium. And we have discussed about air circuit breaker, in which air is the arc quenching medium. And we have already discussed about SF6 circuit breaker, in which SF6 gas is the arc quenching medium. Okay, so when compared to all the other circuit breakers, it is observed that the dielectric strength and the arc quenching ability or arc interrupting ability of this high vacuum is superior. Okay, and if you compare this vacuum circuit breaker or the high vacuum dielectric strength and arc interrupting ability with respect to the air and SF6 at atmospheric pressure, then it is observed that the dielectric strength of high vacuum and the arc interrupting ability is high when compared to air and SF6 at atmospheric pressure. Okay, so if you take SF6 gas at an atmospheric pressure of 7 and air at 25 atmospheric pressure, having it is observed that this SF6 gas at 7 atmospheric pressure and air at 25 atmospheric pressure have high dielectric strength when compared to high vacuum. Okay, of course, high vacuum has more dielectric strength and better arc interrupting capacity at atmospheric pressure, but at an atmospheric pressure of 7 for SF6 and at an atmospheric pressure of 25 for air, they have better dielectric strength when compared to high vacuum. Okay, so a pressure of around 10 to 5 mm or below is considered to be high vacuum. Okay, so in high vacuum, charged particles moving at such a means such a pressure which is around 10 to 5 mm of mercury or below it will not cause any collision with the molecules of the residual gases. Okay, so we already know that whenever circuit breaker contacts are opened in gas, arc is formed due to ionized molecules of gas. Okay, so the mean free path of the gas molecules is small, and the ionized process multiplies the number of electrons to form an electron avalanche. Okay, so in high vacuum, arc electrons and ions do not come from the medium in which the arc is drawn, but they come from the electrode due to the evaporation of its surface. Okay, so because of the evaporation of the electrode surface material, okay, in vacuum circuit breaker there will be arc electrons and ions. Okay, so the breakdown strength in vacuum circuit breaker will depend only on the gap length, okay, and surface condition and the material of the electrodes. Electrodes means contacts. Okay, here electrodes means contacts. So the breakdown strength will always depend on the gap between the contacts and surface condition of the contacts and material with which the contacts are made up of. So this is a vacuum circuit breaker. Okay, so let us discuss in detail about its construction and working. So I have connectivity issue. One second. Okay, one second. There was connectivity issue. Roll number 225, 19 kb. Okay, so let us discuss about the operation of this vacuum circuit breaker. So this is the insulating envelope. Okay, this is the insulating envelope in which all the circuit breaker contacts are placed. Okay, this insulating envelope is made up of glass or glass fiber, reinforced plastic or porcelain. Okay, and inside this insulating envelope there is a vapor condensation shield. Okay, so this condensation shield is made up of synthetic resin. This is the condensation shield. Okay, this is the condensation shield. It is made up of synthetic resin. This shield is provided to prevent the metal vapors, okay, reaching the insulating envelope. Okay, two metal end flanks are provided. Okay, you can see here two metal end flanks, shield support flank is there. Okay, so two metal end flanks are provided here. Okay, so they support the fixed contact and the outer insulating enclosure, vapor condensing shield and metallic below. Okay, this is the metallic below. Okay, this is the metallic below. You can see below here. If you want, I can show one more image. This is the metallic below. Okay, this is the fixed contact. This is the moving contact. This is the shield, and the outer cylindrical portion is our insulating envelope. Okay, so when compared to that image, you can see here, this is the flank and this is the flank. Okay, metal flanks. Okay, these two are the flanks, the upper one and the lower one. Whereas in this diagram, they are provided on the means in the horizontal means in the middle. Okay, whereas in this they have provided at the upper and the lower portion. These flanks are provided. Okay, to give support. Okay, the purpose of flank is only to give the support to the structure. Okay, so these are the moving contact and the fixed contact. You can see here fixed contact. This is our fixed contact. This is our moving contact. Okay, so moving contact is connected to this lower below. Okay, it is the metallic below. Okay, so this is the shield of this metallic below. Okay, this is the shield of this metallic below. So we can call these contacts circuit breaker contacts, that is the moving contact and the fixed contact, as the interrupter. Okay, arc interrupter. We can call them as arc interrupter. Okay, so this arc interrupter means the moving contact and the fixed contact. Okay, so you can see here these contacts, moving contact and fixed contact together, you can call them as electrodes. Okay, so they are sealed. They are having a sealed construction. Okay, stainless metallic below is connected to the moving contact. Okay, So one end of the metallic below is welded to the moving contact. Okay, one end of this is welded to the moving contact, other end is welded to the lower end flange. Okay, so this actually I have shown you another image. In that image, this lower portion is the flange and this upper portion is the flange. Okay, so these two are the supporting flanks, of course. Okay, so this to the lower flank, this metallic below is welded, and to the moving contact, this metallic below is welded. Okay, copper bismuth or silver bismuth or silver lead or copper lead are good materials for making the circuit breaker contacts. So these circuit breaker contacts means these electrodes. Okay, these electrodes are made up of either copper bismuth, silver lead, and copper lead. Okay, so under normal operating condition, both the contacts will be in contact with each other. Okay, so whenever a fault occurs, these contacts will separate in high vacuum. Okay, when these contacts are separated in high vacuum, what will happen? Arc is struck between these two contacts because of the operation of these contacts, means electrodes. Okay, and this arc which is struck between these two contacts does not take place in the entire surface of the contacts but only on few spots. Okay, the arc which is struck between these two contacts, that is these two electrodes, will not cover the entire surface of these two electrodes. These two are the electrodes, contact electrodes. Okay, and it will means the arc will be struck at only few points. Okay, so the contact surface is not perfectly smooth. You can see in one more image here. I have shown you. This is the contact surface. Okay, so the contact surface is not perfectly smooth. This image is not visible with our naked eye. Okay, this is the contact surface, which is not means it's not smooth here. You can see, but it is not visible with our naked eyes. Okay, remember that. It has certain micro projections. You can see the micro projections here. Okay, at some places micro projections are there. Okay, projections are there. Okay, so at the time of contact separation, when these two contacts are separating, these projections form the last points of separation. Okay, these projections will form these projections. Okay, these are the projections. These projections will form the last point of separation. The current flows through these points of separation, resulting in the formation of few hot spots. Okay, so when current flows those two projections, what will happen? That will result into hot spots. You can see some red dots here. Okay, red dots represent the hotspots. Of course, in your UEP, utilization of electrical power subject, you might have learned about hotspots. Okay, so mean uneven distribution. Whenever there is uneven distribution of heat on the surface of a metal, okay, so whichever portion is more heated, that will look red. Okay, of course it is not visible with our naked eye. Okay, it is not visible with our naked eye. Okay, so but that will be more heated, means red, wherever you can see the red portion, that is more heated. Okay, so other portions are less heated, but heat should be, means I am talking with respect to the UEP subject, heat should be distributed uniformly throughout the surface of a metal. Okay, so if it is not distributed uniformly, that means that hot spots will occur, means some portion will be heated more and then when compared to the other portion. Okay, let us come to STP subject. Okay, so these hot spots, which these red portions, whatever you can see, these hot spots will emit electrons and act as cathode spots. Okay, these hot spots, red spots, will emit electrons and they will act as cathode. Okay, and this contacts, the electrode, means moving contact and fixed contacts, they have large disc shaped faces. You can see a disc shaped face here. Okay, fixed contact and moving contact are having disc shaped faces. These faces contain spiral segments. You can see the spiral segments in this image. On the face of this disc, you can see the spiral segments, so that arc current produces axial magnetic field. Okay, so in order to produce axial magnetic field by this arc current, these contact faces are spiral in shape. Okay, so The movement of the arc over the contact surface minimizes metal evaporation and hence erosion of the contact due to the arc. Okay, so due to this axial magnetic field, okay, because of this axial magnetic field, movement of this movement of the arc over the contact surface will minimize metal evaporation and hence erosion of the contact due to arc. So the contact separation will be only about 1 centimeter. That means the distance between these two contacts when arc is struck between the contacts is only 1 centimeter, and which is adequate for current interruption in the vacuum. Okay, so this distance of 1 centimeter between moving contact and the fixed contact is adequate for current interruption in vacuum. Okay, so this circuit breaker is very compact circuit breaker. Power required to close and open its contacts is much less when compared to the other type of circuit breakers. Okay, so it is capable of interrupting capacitive and small inductive currents without producing excessive transient over voltages. Okay, so this is about the operation of this circuit breaker. So let us discuss the advantages of this circuit breaker, vacuum circuit breaker, advantages, disadvantages and applications. Okay, so this we already know that the circuit breakers does not require any additional filling of oil or gas. Okay, so since they does not require any additional filling of oil or gas, they do not need any periodic refilling. Okay, so rapid recovery of high dielectric strength on current interruptions, that is only a half cycle or less arcing occurs after proper contact separation in these circuit breakers. That is one of the advantage. So breaker unit is compact and self-contained, and it can be installed in any required orientation. Okay. And when the voltage is high and current to be interrupted is low, these breakers have definite superiority over the other breakers. Okay, so these vacuum circuit breakers are preferable for interrupting high voltages and low currents when compared to other circuit breakers. These are preferred for high voltages and low currents. So for low fault interrupting capacities, the cost is low in comparison to other circuit breakers. Okay, so whenever we want to interrupt a low fault, the cost for vacuum circuit breaker is less when compared to other circuit breakers. So let us discuss the disadvantages. So there is requirement of high technology for production of vacuum interrupters. It needs additional surge suppressors for interruption of low magnetizing currents in a certain range. That is one of the disadvantage. Loss of vacuum due to transit damage or failure makes the entire interrupter useless and it cannot be repaired on site. Okay, these are the disadvantages. Applications are because of the short gap and excellent recovery of vacuum circuit breakers, they are very useful as very high speed making switches in many industrial applications. Okay, so they are used as high speed making switches in many industrial applications, and because of the least requirement of maintenance, these breakers are very suitable for the system which requires voltage from 11 to 33 kilovolts. Okay, so these are suitable for voltages of around 11 to 33 kilovolts. Okay, these are the applications. Okay, next is circuit breaker rating. Let us discuss. We have discussed classification of circuit breakers is over. We have discussed all types of circuit breakers. Okay, oil, air, SF6 and vacuum circuit breaker. This other types of circuit breakers that we have discussed, that is based on the medium in which circuit breaker contacts are placed. Okay, classification of circuit breakers based on the medium in which circuit breaker contacts are placed. According to that, we have discussed types of circuit breaker. Okay, so let us discuss about the circuit breaker ratings. Okay, so so the rating of the circuit breaker is given according to the duties that are performed by it. Okay, depending on what type of duties this circuit breaker performs, depending on the duties performed by it, ratings are provided. Okay, so according to Indian standard 375 by 1951, according to the Indian standard, so Indian standards will give the complete specifications, standard rating and various tests for switches and circuit breakers. So if I want to know the complete specifications, standard ratings and various tests for the switches and circuit breakers, I must follow the Indian standards 375 and 1951. Okay, so it will give me the complete specifications that are required for, depending on my requirement, I can follow those specifications. Okay, so apart from normal working of circuit breakers, the circuit breaker is required to perform some three major duties under short circuit condition. So what is the need of circuit breaker? The circuit breaker is required to interrupt the circuit under fault condition. Okay, so we want to clear the fault under clear the fault if fault occurs in the system. Okay, so whenever short circuit occurs in a system, the circuit breaker should perform three duties. The first duty is the circuit breaker must be capable of breaking the circuit and isolating the fault section in case of fault. Okay, so as soon as fault occurs, what the circuit breaker should do? It must be able to break the circuit and it must be able to isolate the faulty section. Okay, so this is known as breaking capacity of the circuit breaker. So what is breaking capacity? Breaking capacity is the ability of the circuit breaker to break the circuit and to isolate the faulty section whenever fault occurs. Okay, next duty of the circuit breaker under short circuit condition is that, okay, so in general a circuit breaker is put on 2 to 3 times. Okay, next duty. So circuit breaker is put on 2 to 3 times in order to ensure permanency of fault. That is, it must be capable of making circuit on the greatest asymmetrical peak in current wave. Okay, so even if an asymmetrical short circuit current is there in the system, which is to be protected by the circuit breaker, okay, as soon as fault is cleared, the circuit breaker must immediately close. Okay, so this is referred as making capacity of the circuit breaker. Okay, so making capacity is as soon as fault is cleared, even if it is a asymmetrical fault, okay, as soon as it is cleared, immediately it should make the circuit. So that is known as making capacity of the circuit breaker. Another duty of the circuit breaker is whenever circuit breaker is operated along with some other circuit breaker, okay, so in maybe nearby circuit breaker may be there, okay, so in series to this circuit breaker, so whenever a circuit breaker is operated along with another circuit breaker, not at the same location, maybe somewhat far away from it, okay, in case of fault in any one section, okay, if fault occurs in any one section, the breaker must operate without tripping. Okay, means if whenever two circuit breakers are operating at two different locations, maybe nearby to each other, okay, if fault occurs nearer to another circuit breaker, that breaker should, when that breaker is interrupting the fault, this breaker should not try to interrupt that fault. Okay, because when one circuit breaker is operating, another breaker should mind its own business. It must do its own, it must allow the normal current to flow in its own section. Okay, it should not interrupt in the duty of another circuit breaker. Okay, so circuit must be capable of carrying fault current safely for a short time while another circuit breaker is clearing the fault. Okay, so it should not, when one circuit breaker is operating, another circuit breaker should not operate in order to clear the fault. Okay, this is referred as short time capacity of the circuit breaker. Okay, short time capacity of the circuit breaker means even though fault has occurred, okay, when another circuit breaker is interrupting the fault, this circuit breaker should not interrupt the fault. Okay, so these are the three duties which are to be performed by the circuit breaker. Okay, so in addition to this above three duties, that is rating, okay, circuit breaker should be specified in terms of number of poles, rated voltage, rated current, rated frequency, and operating duty. Okay, so number of poles means the number of poles per phase in a function of operating voltage. It's nothing but number of poles. Okay, so let us go for the next one, that is rated voltage. Second one is rated voltage. Okay, so under normal operating condition, voltage at any point of the power system is not constant. Okay, definitely. Okay, so under normal operating condition, the voltage at any point of the power system is not constant. So due to this, the manufacturer will give a guarantee that whoever manufactures the circuit breaker, he will give a guarantee that at rated maximum voltage, okay, the circuit breaker will be operated at rated maximum voltage. It will be able to operate at rated maximum voltage, which is a rule, which as a rule is higher than rated nominal voltage. Okay, so the manufacturer who manufactures the circuit breaker, so he will give a guarantee that even though the rating of the circuit breaker is so and so, it will be able to operate beyond its limits. That's the meaning of this line. Okay, so beyond its rating, it will be able to operate. The rated maximum voltage of circuit breaker is the highest RMS voltage above the nominal system voltage. Okay, so the rated maximum voltage of a circuit breaker according to this manufacturer is the highest RMS voltage above the nominal system voltage for which the circuit breaker is designed and is the upper limit of the operation. So the earlier practice of specifying the rated voltage of circuit breaker as nominal system voltage is no more followed. Earlier, the whatever rating was there for the circuit breaker, it was its maximum voltage. Nowadays, it is not followed. The rated voltage is expressed in kilovolts RMS and referred to phase-to-phase voltage for three-phase circuit. Okay. Next, rated current. The rated normal current of a circuit breaker is the RMS value of current which the circuit breaker shall be able to carry at rated frequency and at the rated voltage continuously under specified condition. So rated nominal current of a circuit breaker is the RMS value of the current which the circuit breaker shall be able to carry at rated frequency and at the rated voltage under specified conditions. So under the specific conditions, so important is the temperature rise of the various components of the circuit breakers under normal load conditions. So temperature must be continuously monitored under normal load condition of the circuit breaker. Okay. So for example, if you take oil circuit breaker, the important condition for normal working of the oil circuit breaker is the temperature rise of the oil should not be more than 40 degrees Celsius and that of the contact should not exceed 35 degrees Celsius. Okay, so while operating, when current is flowing through the circuit breaker parts, we must make sure that the temperature does not rise too much. Okay, so the temperature must be monitored continuously. Next is rated frequency. The rated frequency of circuit breaker is the frequency at which it is designed to operate. Okay, so the frequency at which the circuit breaker is designed to operate is the rated frequency. According to Indian standard, the rated frequency is what? It is 50 hertz. Okay, so applications at other frequency needs special considerations. Next is operating duty. The operating duty of circuit breaker consists of the prescribed number of unit operations at stated intervals. Okay, so the operating sequence denotes the sequence of the opening and closing operation when the circuit breaker can perform under specified condition. Okay, so the circuit breaker can perform under specified conditions certain operating sequence. Okay, so the sequence of opening and closing operations which the circuit breaker can perform under specified conditions is known as the operating duty of the circuit breaker. Okay. Next is the breaking capacity. So breaking capacity is the term which expresses the highest RMS value of the short circuit current that the circuit breaker is capable of breaking under specified conditions of transient recovery voltage and power frequency voltage. Okay, so I have already given a proper definition for breaking capacity. So breaking capacity is the term which expresses highest RMS value of short circuit current that the circuit breaker is capable to break down under specified conditions of transient recovery voltage and power frequency voltage. Okay, so this breaking capacity is expressed in kiloampere RMS at contact separation, and it can be seen from the short circuit current wave that the RMS value of current varies with time on account of presence of DC component of current which decays with time and can be seen from short circuit current wave. Okay. So let us see what is this short circuit current wave. So just now I have told you that the RMS value of current varies with time on account of presence of decaying component of current which decays with time. Okay, this is the DC component of current which decays as the time varies. This is the time, x-axis is the time, y is the short circuit current. Okay, so this DC component current is gradually decaying with respect to the time. Okay, this is a short circuit current waveform. So it is observed that as soon as fault occurs, instant of short circuit. Okay, you can see here in this image, this is the instant of short circuit. At the instant of short circuit, it is observed that the current becomes maximum. Okay, you can see here the current has become maximum. The current has become maximum at the instant of short circuit. Okay, immediately as soon as short circuit occurs, current becomes maximum. The current is approximately, let us assume it as I peak. Okay, is maximum at the instant of short circuit. Later on, yes, current will reach to its peak value, and later on it is decaying. Okay, and we know as soon as short circuit occurs, the circuit breaker cannot sense the fault. Okay, it is the relay which will sense the fault. Okay, and it has to give a signal to the circuit breaker. Okay, so so as soon as the trip circuit of the relay is energized, okay, the trip circuit will be in connection with this circuit breaker moving contact. So the trip coil gets energized of this trip circuit, and the trip coil will pull away the moving contact of the circuit breaker from the fixed contact. Okay, it will take certain time. Okay, so you can see here after certain interval of time, the instant of parting of the arcing contacts means after certain interval of time, circuit breaker contacts are open. So let us assume the time taken for the circuit breaker contacts to open is small t. Okay, the time taken for the circuit breaker contacts to open is small t. Meanwhile, when the circuit breaker contacts are opening, if you can observe the current has the magnitude of the current, fault current, short circuit current has reduced here. Okay, so the instant when circuit breaker contacts are open, the amount of current that these circuit breaker contacts have to interrupt has reduced. Okay, so it is not the current which has occurred immediately as soon as short circuit occurs. Okay, so the short circuit, when as soon as short circuit occurs, the short circuit current has reached to the maximum value. This is the magnitude. As soon as circuit breaker contacts are open, you can observe as the DC component is decaying, the magnitude of this short circuit current is also decreased. So the amount of current that is to be interrupted by the circuit breaker is reduced. Meanwhile, it receives the signal from the relay. Okay, so it takes some time for the circuit breaker contacts to open. Okay, instantaneously as soon as fault occurs, the circuit breaker contacts will not open. Okay, because of the relaying action. Okay. Okay, so hence the actual current interrupted by the circuit breaker is less than the initial value of short circuit current. Initial value of short circuit current is what? I peak. Okay, let us assume let the instant of separation of contacts, at the instant of separation of contacts, and you can see the envelope of this current wave, short circuit current wave, this dotted line. This is the dotted line. In between these two dotted lines is this is the envelope of the short circuit current. Okay, So let us assume AB is the AC component of short circuit current and BC is the DC component of short circuit current. So okay, so I have something I have written. Yeah. So AC is the component of short circuit, that is IAC, and DC is the component of short circuit. Uh, DC component of short circuit current and AC component of short circuit current. Okay, so AC component of short circuit current is, let us assume it as X, and DC component of short circuit current, let us assume it as Y. Okay, now the symmetrical breaking current is given by, depending on this short circuit current waveform, is given by RMS value of the AC component of short circuit current at the instant of separation of the contacts is given by X by root 2. You know what is meant by X now. Okay, X is the AC component of short circuit current, Y is the DC component of short circuit, and the symmetrical breaking current is given by RMS value of the combined sum of AC and DC components, that is root of X by root 2 whole square plus Y square. Okay, so this is it. Now, according to the breaking currents here, two corresponding values of breaking capacities are there. One is the breaking capacity of circuit breaker in megavolt ampere. Okay, so the breaking capacity of the circuit breaker in megavolt ampere is given by root 3 into rated value of voltages in kilovolt into rated breaking current in kiloamperes. Okay, so this practice of specifying breaking capacity in terms of MVA is convenient while determining the fault level. So whenever we are specifying the breaking capacity in megavolt ampere, it is convenient for determining the fault level. However, as per revised standards, okay, the breaking capacity is expressed in kiloamperes for specified conditions of transient recovery voltage, and this method takes into account both the breaking current and transient recovery voltage. Okay, there are two breaking capacities that can be defined. Okay, so one is the symmetrical breaking capacity of circuit breaker. This symmetrical breaking capacity of circuit breaker is the value of symmetrical breaking current which the circuit breaker is capable of breaking at a stated recovery voltage and stated reference restriking voltage under prescribed conditions. Next one is asymmetrical breaking capacity of circuit breaker. So this asymmetrical breaking capacity of circuit breaker is the value of asymmetrical breaking current. Okay, asymmetrical breaking capacity of circuit breaker is the value of asymmetrical breaking current which the circuit breaker is capable of breaking at a stated recovery voltage and a stated reference restriking voltage under prescribed conditions. Okay, so we'll continue this ratings of the circuit breaker in the next class. Or shall I complete? Okay, you have another class at 11:30, so leave it.